Okay, so today we're looking at the domain and range of discrete functions. Remember, discrete data, this is values that belong to a set of distinct and separate and unconnected values. They can be counted, often use the or preceded by the phrase number of, so like number of tickets sold or number of customers. Our next lesson is going to be continuous data, which we'll talk about in a little bit. But continuous data is that there is a connection. With discrete, they are separate, so they are written using dots, which is why we have for our notes this discrete is written in dots, and we'll talk about continuous later on. So discrete data, understand that our domain and range are still the same. The domain is all the x values. My range, I'm going to go ahead and write in a separate color. My range is all my y values. So when I'm looking at these ordered pairs, remember, ordered pairs are written in x, y. So these are all my x values. These are all my y values. And so when I write this domain and range with discrete data, I use brackets. So these are special brackets for sets of numbers. It's not a big deal if you can't draw it perfectly and you draw parentheses instead. It will be perfectly fine. I'm definitely looking more so towards what numbers you have written down. So for the x values, we have -2, we have 0, we have 5, and we have 8. For our y values, I tend to, whenever I write these, write them so they're matching sets. So the -2, the 3 goes with the -2, the -1 goes with the 0, the -7 goes with the 5, and the -2 goes with the 8. Officially, we would normally list them in least to greatest fashion, but for our purposes here, it's most important that to me that you're identifying what the x values are and what the y values are. In a table, identify which part is our x part of the table. This is x, the number of boxes. This is y, the total weight. So our x values are 1, 2, 3, and 4. And our y values are going to be 0.5, 1, 1.5, and 2. Another thing I want you to notice is all of these are functions. Discrete data and continuous data is always going to be listed as functions. They are a subset of functions. Mapping, this is something that is kind of uncommon for us. We don't really tend to do it anymore like this. But mapping, it'll have all of our x values right here, and then all of our y values right here. We don't really use mapping all that much anymore because we would use a table instead, because if it was up to us, we would graph the data. But mapping can and you may see it on a quiz or a test. -0.5, -8, and -13. For our graph, this is a pretty common way for us to ask the domain and range of discrete data by giving you a graph. So for the graph, I'm going to actually list the points first. So this is -3, and then this is my y value, which is 3. This right here is -1, and my y value is -2. If you notice, I'm still using the pattern of using the blue marker for my x values and the kind of purplish marker for my y values. And yes, the 0.00 is right there. It's being used. That point is 3. This one is -4. This one is 4. And that one is 4. So when I list my domain data set, I have -3, -1, 0, 3, and 4. For my range, I'm going to again list them in pairs with the domain values, it's just a way for me to make sure that I'm listing the correct ones. That way I know. Now, this is going to be the last two are the most common ways that you are going to be asked for the domain and range of discrete functions, and for discrete functions for sure. Continuous, we may give you a graph instead. But for the first one, it's equations. And so here's what I want you to do. I'm gonna write an x value right here, and I'm gonna write my y value right here. So remember, a function is just the input. The x values are the input, and the y values are the output for the function. So it gives me my domain, -1, 0, and 1. And in fact, I'm going to go ahead and list my domain, -1, 0, 1. Now, in the function itself, we have the function y equals 2. I'm going to write, instead of x, I'm going to write -1 plus 1. 2, instead of x, I'm writing 0. Because this is my domain values. Those are the values that are being plugged into the equation. I'm going to write 2, parenthesis, 1 plus 1. Then I complete the function in order to figure out my output. -1 times 2, that's -2, plus 1, that's -1. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. So my range is -1, 1, 3. The other way that we could have used or figured this out is using Desmos and plugging the equation into Desmos and building a table off of that, which I showed in class. I don't have the ability to show it here, but I did show it in class, and it's something we'll go over. The last one, verbal. This is probably the most common. It's the last 2 ways it's been on the state test. It's probably going to be on your test. Graduation tickets cost $15 per person. Each student can buy a maximum of 3 tickets. So my domain is the number of tickets students can buy. Number of tickets. So then the question becomes, how many tickets can a student buy? Well, it says they can buy a maximum of 3 tickets. So that means they could buy no tickets, 1 ticket, 2 tickets, or 3 tickets. So therefore, the range is the cost, how much money they have to spend. Well, if they bought 0 tickets, they spent no money. If they bought 1 ticket, it was $15. If they bought 2 tickets, that's $30. And if they bought 3 tickets, it's $45. There's nothing beyond this because the student can buy a maximum of 3 tickets. We did have an assignment in class. If you have any questions about domain and range of discrete functions, please come in before or after school or ask during class. Thank you so much.